Okay, today we are going to test your ability to solve word problems. So, up on the monitor here is a fairly straightforward, what I call a word problem. So, I'd like you to take a minute, get out a calculator, get out a piece of scratch paper, and go ahead and solve this problem. Okay, now some of you maybe looked at this and you saw it was a word problem and it gave you a headache because you hate word problems. Maybe others of you are like, yeah, I can figure this out. And maybe some of you got the right answer of 852 milliliters. So if you did, congratulations. What we want to look at today is to give you a good setup for how to solve a problem like this. This one, it wasn't a super easy one, but it really wasn't that bad. But we want to talk about having a really good process for solving these problems. So if you really struggled with even how to do this one, this is going to help you out tremendously. If you did get the question right, my answer is, well, how was your setup? Does your numbers just kind of look like a lot of number vomit on your paper and then magically there's an answer, Or did you set it up real nicely? Is it easy for someone to follow and can they see exactly how you got your answer? Okay, this is not a real great example for how to get the correct answer. So we're going to walk you through this process. So what I actually want you to do is in your package, you can turn to page 7 and you will see on page 7 in your packet, you actually have on the top half of the page some steps for doing what I call a problem, a word problem. And then on the bottom, you have this exact same question. And I'll show you, we want to walk through and take a few minutes, and I'll show you exactly how I would set this question up so that your work can be followed, because it's really, really important not just to get the right answer, but it's really important for people to be able to follow your process, and that you can give your work to somebody else and it doesn't look like this, they should be able to follow it and see how you got it. Or you should be able to come back to your work a month, 2 months later and be able to see how you got that answer and not just from just grunting math work out here. So um, for our steps, and again, up at the top, you have this, what you see on the right of your screen is up on the top half of your page. And we're going to work through this example problem here as we follow these steps. So the first step that I say when you're solving again, what I call a word problem, is to make a data table. Now, a data table doesn't have to be a big fancy box or anything like that. But what I like to do when I'm solving a problem like this is I like to make what I call a T-chart, which is really what I already have done here. So if you just kind of imagine, okay, I was drawing this, and so that's kind of like a really off-center T. So we've already kind of set this up where we have a line drawn. We're going to make our data table on this side, and then over on this side is where we're going to show our formulas and do all of our work. So make your little T-chart, and we're first going to start with this data table section. Now the data table is very simple. In your data table, you're simply going to list and label what you know from just reading the question. So as we read the question, we want to look at our information. Okay, I know that my object is 3.17 grams per milliliter. So I've listed that information, but the really, really important part is to label that. What kind of information is that? And so this is where we have to look at the units. And hopefully by now you're starting to learn your units a little bit. And hopefully by now you recognize if you see grams per milliliter, that is a unit of density. So I'm going to label that as my density. Might seem like a silly step, but it's really, really important to make this process very, very easy. Okay, so I'm going to continue listing and labeling. What else do we know? Okay, we know the object is 2.7 kilograms. And hopefully you know that when you see units of kilograms, that is the mass. Of course, in this case, the question actually says it's the mass. Now, also when you're making your data table, that's everything that we know in the question. But the other thing we want to include is what the question is asking us to find. In this case, it's asking us to figure out how much space our object occupies. Now, again, hopefully when you hear that phrase, space the object occupies, some bells and buzzers are ringing in your head, and you're going, oh yeah, I know what that is. That's the volume. That's our definition of volume, the amount of space an object occupies. So I want to label that, and maybe you put a blank, or maybe you like to put a question mark, something like that. That's all we have to do when we make a data table. So we haven't even begun to be confused or try to think about how we're going to answer the question. We simply did that. Okay, so before you get stuck and before you go saying, oh, I don't know how to do this problem, do your data table. You can do that. A lot of times it will help show you how to solve the question. Okay, so after we've made the data table, now we want to think about, okay, do I know any formulas or anything that I can use to help solve this problem? Now, as of now, we don't know a whole lot of formulas, so this is probably easy to figure out. So take a look at the kind of information we know. We know density, mass, and volume. Do we know any formulas that have density, mass, and volume in them? And by now we should know that density is equal to the mass divided by the volume. So I'm going to write that formula down. Notice there's no numbers in it. I wrote it down first. Okay. I've got the same variables as I have on my data table. So a lot of times it's really obvious what formula you need to use. Now here's a really, really important step. Number 3 is really important. Before I start plugging all my numbers into this, I want to look at my formula and see, do I have my formula arranged for what I'm trying to solve for? My main formula that I have memorized is solve for density. But in this problem, I'm trying to figure out volume. So what I really, really, really would like you to do is before you start popping numbers in, is to solve this thing. In this case, we're trying to find for volume. So let's do our algebra and solve it for volume. Okay, now, again, there's a lot of different algebra ways to do this. In this case, whenever what I'm looking for is in the denominator, I hate it when things are in the denominator. So first thing I like to do is get them out of the denominator. So one way we can think about doing this is by cross multiplying. If we think of the d as d over 1, let's just cross multiply. So we've got d times v is equal to m times 1. Okay, or in other words, d times v is equal to m. Now, maybe you just right away decided, hey, I'm going to multiply both sides by v. Perfectly fine, too. But we're not done because our goal was to get v by itself. I got it out of the denominator, which is fine. But now my last step is I need to get rid of this d. So to get rid of multiplication, you divide. So we're going to divide one side. Of course, the golden rule. Whatever you do to one side, you have to do the same thing to the other side. So we're going to divide both sides by d. So my d's cancel out. So my formula is v equals m over d. Okay, I know that sounded like a lot of work, and I just went through the algebra because I want to make sure you're doing proper algebra, not just moving things around. Make sure you're using proper algebra on this. But it still is way easier to multiply and divide or slash move around a bunch of just letters when it's just V's and D's. If I had plugged my numbers and units in right away, then that's actually a whole lot more work. Plus, it's easier for someone to follow when you've rearranged just the formula first. So please rearrange it first, get it solved for what the question's asking you to do before you start to plug the numbers and the values in, okay, which is in fact our next step. Our next step is to go ahead and plug the values into our formula. So I'm just going to rewrite our formula up on top here, V equals. So now in place of M, I can plug my value for M in. And I know my value for M is 2.7 kilograms. And then I'll divide that by my density, which is 3.17 grams per milliliter. Okay, so now I've plugged those in. Now, a lot of people at this point in time want to just plug that in, or sometimes they just write the numbers in and then they pick up their calculator and say, okay, let's take 2.7, let's divide that by 3.17, and we get an answer of 0.851735. Wrong answer. Okay, very, very wrong answer to the question. And the reason why these people get this wrong, if they get that answer, is they're not paying attention to the units. So before you pick up your calculator and start plugging numbers in, you actually want to look at the units first. So notice when I say in step number 4, when it says plug in the values, notice I did not just plug in the numbers, I also included the units. Okay, those are just as important part of the mass, Those kilograms there is just as important as the 2.7. So never just put numbers in and then slap a unit on at the end. Those units are part of all of your values, and so they're part of your calculation. So you want to plug them in when you're include those units when you're plugging them in. And then before you even go to pick up your calculator, before you do that, step number 5 is actually to calculate the units first. Okay, so just like if you're doing an algebra problem, maybe in algebra you've got 3x times 4y. Uh, you don't just say, well, the answer is 12. Okay, you've got to calculate both the number part and the unit part. So we've got to say, well, all right, so x times y, well, that's going to be xy. So that's kind of the unit part of my answer. And then 3 times 4 is 12. That's the number part of your answer. So you kind of do 2 sets. Let's look at the units, and then let's look at the numbers. So we've got to do the same thing here. Okay, if I look at my units, now this is kind of a mess because when I look at this case, I see I have mismatched units here, or in other words, my units are not in sync with each other because here I have a mass unit of kilograms. Now, even though this is a density unit below, there's a mass component there, but that's in grams. So my mass components are not in sync with each other. And so because of that, my units don't cancel out, and I don't get, I should get an answer of milliliters, but in this case, it doesn't cancel out or come to that. So since I'm looking at my units first, I realize this isn't good. So I need to get both of my mass components to be the same, and probably the easiest way is to change this 2.7 kilograms into grams. So you might want to do a little work on the side, maybe, and maybe you can do that one in your head. Kilograms to grams is pretty easy. But if you don't like to do that in your head and you want to still use factor label method, okay, since we're kind of new at that, you might work that out. Say, okay, I've got 2.7 kilograms. Your no-brainer step is to put kilograms on the bottom. We want to change it into grams. And who's bigger? Kilograms is bigger, so the 1 kilogram. So how many grams are in 1 kilogram? Kilo means 1,000. And so looking at this, all I have to do is multiply this times 1,000. So 2.7 kilograms is the same thing as 2,700 grams. So when I go to solve my problem here and I go to put my mass in, instead of putting the 2.7 kilograms, we're just going to replace that with 2,700 grams. It's the same thing. It's just now my units will be in sync with each other. And then now when I look at that, over my 3.17 grams per milliliter. Now I can see, all right, I feel better. My mass units are in sync. Now we still have to calculate the units. And again, just use your algebra here. Treat these just like X's and Y's. We've got grams over grams per milliliter. So we've got a complex fraction. But remember, your trick is to invert the denominator and then multiply it times the top. Don't just say, oh, there's the G, there's the G, they cancel out. Make sure you're doing proper algebra on this. So I can simplify this by taking my denominator, invert it, and now we're multiplying that times the top. So I've got G, and if you want to think about it as grams over 1, times milliliters over grams. So I've got grams on top and grams on the bottom. That cancels out, and I have milliliters over 1, which is the same thing as milliliters. So when I simplify my units here, my units come out to milliliters. I'm going to rewrite that now. Volume is milliliters, and of course that's a good thing because milliliters is a volume unit, and I'm trying to find the volume. So now I've got the green light. We've got double thumbs up here. Our units are set up. So now we're ready to just pick up our calculator and take our 2,700 and divide that by our 3.17. And we'll deal with the issue of how to know where to round to later on. Your calculator gives you this big monster long answer. I'm going to round that just to 852. That is a good question that we will deal with something called significant figures, but that's how we got the answer. Okay, so again, just looking at my work here for how I solved this problem. Now, there's nothing about my handwriting that's pretty, but hopefully you'll realize that, hey, you know what, we can follow our work. There's our data table. There's the formula we used. We've mutilated it a little bit because we've rearranged it, but there's the formula that we used. There's the work plugged in with units. There's our final answer with units. Okay, so again, even though you might have been able to come up with the correct answer to this question fairly quickly, looking something like this, please, we want to get you into good habits. Again, if you have good habits for fairly simple problems, then as problems get harder and harder and harder, those good habits are going to just pull you right through, and harder problems really don't become that much harder. They just become longer. Okay, so please bear with me and stick with this. So I hope that helped, and we'll be looking at lots more examples as we go through the course.